the derivatives of inverse trig functions. Our goal is to find the derivative of the arcsine of x, at least to start. How can we do this? Well, we want to use something that we already know. So let's start by taking the sine of both sides of the equation, given a sine of y equals x. Recall that the arcsine and inverse sine mean the same thing. And if I do the sine of the inverse sine, we get just the argument right there. Now, why do we want to do this? Well, it's because we know the derivative of sine of y already. Now, recall that we want to find the derivative of this with respect to x. So we're going to take the derivative of this equation, sine y equals x, with respect to x. So we're going to do a little bit of implicit differentiation. We're going to use a chain rule. If you haven't watched those videos, either one, I recommend that you go back and watch them. But if I take the derivative of the sine of y, we get the cosine of y. Now, since our variable doesn't match because we're taking the derivative with respect to x, we got to do times dy dx. And then equals the derivative of x with respect to x is simply 1. This gives us that dy dx equals 1 over the cosine of y. So this dy dx is the derivative of the arcsine of x, right? It's the same y here as the same y right there. But we really want to find this derivative, not in terms of y, but in terms of x. So how can we do this? I'm going to draw a triangle to help us understand. In fact, I'm going to draw a right triangle. And if I look at this expression up here, I'm going to rewrite it again, but slightly different. We get the sine of y equals x, or x over 1. So if we're doing the sine of y, y is the angle, and I'll put the angle right there. And if I choose that to be the angle y, where sine is opposite over hypotenuse, I can put x on the opposite side and 1 on the hypotenuse. The Pythagorean theorem gives us the third side, which is the square root of 1 minus x squared. So now we can find the cosine of y in terms of the angle right here. The cosine of y is the adjacent over the hypotenuse. So the cosine of y is root 1 minus x squared over 1, or simply root 1 minus x squared. So dy dx, recall this is the derivative of the arcsine of x, is 1 over the cosine of y, where cosine of y is root 1 minus x squared. And we get the derivative of the arcsine. We're going to do this again, but slightly more general. What if we want to find the derivative with respect to x of the arcsine of u, where u is probably some other function of x, but regardless, the variable u will not match with our derivative. We're going to start the same way. We're going to take the sine of both sides. We're going to get the sine of y equals the sine of the arcsine, which cancel, equals u, or u over 1. I'm going to go in and build my triangle right now. Get a right triangle there, and I will choose y to be that angle. And then the sine is the opposite over hypotenuse. And Pythagorean theorem gives us the third side, root 1 minus u squared. Looks the same. The difference will come over here when we take the derivative of that equation with respect to x. The derivative of sine of y is the cosine of y. But with respect to x, we need the chain out times dy dx. The derivative of u is 1, but my variable doesn't match there either, so we have the chain out times du dx, which means that dy dx, the derivative of the arcsine of u, equals 1 over the cosine of y times du dx, where the cosine of y is 1 over root 1 minus u squared, just like it was, or similar to the problem before it, and then times du dx. So very often when you see the derivative of the arcsine, books will have it in the general case, the derivative of the arcsine of u, and they're often going to write it this way. Instead of 1 over root 1 minus u squared times du dx, they're going to do u prime equivalent to du dx over root 1 minus u squared. So let's take a look at the arctan. And we'll do the general case. What is the derivative of the arctan of u? We will approach it in a similar fashion as the two problems before it, but this time we're going to take the tangent of both sides. So the tangent of y equals the tangent of the arctan, or tangent of inverse tan of u, which is simply u, right? The tan and inverse tan, or tan and arctan, cancel. And we want to find the derivative with respect to x of this. So we will take the derivative with respect to x of our equation, tan y equals u. This will give us secant squared y times the chain out dy dx equals 1 times du dx, or u prime. Let's build our triangle again. And I'll choose the angle y to be there again. And so if the tangent of y is u, or u over 1, the tangent is opposite u over adjacent 1. The Pythagorean theorem gives us the third side. In this case, it's root 1 plus u squared. Now, we need to find what the secant of y and the secant squared of y equals. Well, the secant of y is the hypotenuse over adjacent. So the secant of y is root 1 plus u squared. So the secant squared of y is the square of root 1 plus u squared, or simply 1 plus u squared. And I will write the right side as u prime this time. So we get that the derivative of the arctan of u, that is dy dx in this case, is u prime over 1 plus u squared. Let's do some practical examples of this. What if y equals the arctan of x squared plus the arcsine of e to the negative x? What is the derivative dy dx? Well, the derivative of the arctan of u is u prime, so x squared is u, which means u prime is 2x, over 1 plus u squared, so x squared squared, which of course could have been written in the denominator as 1 plus x to the fourth. And then the derivative of the arcsine of u, where u is e to the negative x, is u prime negative e to the negative x over the square root of 1 minus u e to the negative x, all squared. I will clean this up just a bit, giving us 2x over 1 plus x to the fourth, and then minus e to the negative x over the square root of 1 minus e to the negative 2x. Recall that a power to the power says we need to multiply the powers. Give you one more example with arctan. And this one I'm going to simplify it because this is a nice multiple choice type problem. If I want to find the derivative of the arctan of u, where u is 1/2 x, we get u prime. I'll write it over here again just so we're reminding ourselves. U prime, so the derivative of 1/2 x is 1/2 over 1 plus u, which is x over 2, all squared. Perfectly fine answer, perfectly correct, but it probably wouldn't look like this on a multiple choice test. Let's continue on. This will give us 1/2 over 1 plus x squared over 4. So to simplify this one, I'm going to find a common denominator in the denominator down here, giving us 1/2 over 4 plus x squared over 4. And then if we flip and multiply things, we end up with 2 over 4 plus x squared. So these are the derivatives of inverse trig functions. There are 6. I tend to stick with arcsine and arctan, but let me give you the formulas for all 6. So the derivative of the arcsine is root 1 minus u squared in the denominator and 1 in the numerator. The arc cosine is almost the same, except it's negative. And if you want to see why these are true, just build your triangles, and all these answers come out. The derivative of the arctan of u is, let me go back. I forgot my chain outs because I was doing u. So it's u prime, and then u prime in the top for both arcsine and arc cosine. The derivative of the arctan of u is u prime over 1 plus u squared. The derivative of the arc cotan of u is negative u prime over 1 plus u squared. And then the derivative of the arc secant of u is u prime, remember that's the chain out of the u, over u times u squared minus 1. And the derivative of the arc cosecant of u is negative u prime over u times the square root of u squared minus 1.